today's Mind Hour session. Every day, a lot of changes occur around you all the time. What happens when you keep some ice cubes in a container out in the open? The ice cubes change into water. Similarly, cooking of food, digestion of food, and rusting of iron are all changes around you. Students, here is a paper. Now, I'm going to tear it into 4 pieces. Now, the shape of the paper is changed, but nothing new is formed. However, if I burn the paper, a new substance is formed, which is called ash. So, tearing of paper and burning of paper are 2 different kinds of changes. Tearing of paper does not change the properties of the paper. Only the shape and the size of the paper is changed. But burning the paper changes its properties. Paper no longer remains paper but turns into an entirely new substance, that is ash. So, it is an irreversible change. Therefore, tearing of paper is an example of a physical change and it is a reversible change. But burning of paper is a chemical change and it is irreversible. Every day we come across many types of changes in our surroundings. These changes may involve one or more substances. For example, your mother may ask you to dissolve sugar in water to make a refreshing cold drink. Making a sugar solution is a change. Similarly, setting curd from milk is also a change. Sometimes, if left out for long, milk becomes sour. Souring of milk is a chemical change. You cannot get milk back from the newly formed curd. A stretched rubber band also represents a change, but it is only a physical change because after the force is removed, the rubber band springs back to its original shape. So, there are an endless number of changes happening around us at any given point of time. Today, we shall study the nature of these changes. Broadly, these changes are of 2 kinds, physical and chemical. Now, let us see what changes we can bring in a piece of paper. I can crush the paper, I can cut a piece of paper into 4 square pieces and cut each square piece further into 4 square pieces. Or I can burn the paper. In each case, I will see that a change is happening. Let us observe these changes. I can straighten the crumpled piece of paper. I can lay the cut pieces of paper on the floor or a table so that the pieces acquire the shape of the original piece of paper. Obviously, you cannot join the pieces back to make the original piece, but is there a change in the property of the paper? Now say after I burn this paper, I get ash. Can I get the paper back from the ash after burning it? Now let's take another example. Take a ball of clay and mold it into different shapes. Every time we make a different shape, there is a change. Next, take some ice in a glass or a plastic tumbler. Melt a small portion of the ice by placing the tumbler in the sun. Now you have a mixture of ice and water. Now place the tumbler in a freezing mixture, which is nothing but ice plus common salt. Does the water become solid ice once again? Boil some water in a container. Do you see the steam rising from the surface of the water? Hold an inverted pan by its handle over the steam at some distance from the boiling water and observe the inner surface of the pan. Do you see any droplets there? These were some examples to help us understand the changes we see around us. Now, let us understand the types of change and figure out how they are different. Properties such as shape, size, color, and state of a substance are called its physical properties. A change in which a substance undergoes a change in its physical properties is called a physical change. A physical change is generally reversible and therefore in such a change, no new substance is formed. Salt can be obtained by the evaporation of seawater. The salt obtained in this manner is not pure and its crystals are small. The shape of the crystals cannot be seen clearly. However, large crystals of pure substances can be formed from their solutions. The process is called crystallization. Crystallization is an example of a physical change. Take a cup full of water in a beaker and add a few drops of dilute sulfuric acid. Heat the water. When it starts boiling, add copper sulfate powder slowly while stirring continuously. Continue adding the copper sulfate powder till no more powder can be dissolved. Filter the solution. Allow it to cool. Do not disturb the solution when it is cooling. Look at the solution after some time. Can you see the crystals of copper sulfate? Of course! You will see blue crystals of copper sulfate depositing, and the process is known as crystallization.